Hi, Alex. How are you?
I'm good, and yourself?
I'm good, thanks. I made it through week one, which is it's been intense. How are your classes going? Okay.
Honestly, I'm kind of, I actually, sorry, I'm like all over the place. One of my other classes that I had, the professor, I guess, didn't show up, so they had to change it to another professor, and it's at the exact same time as this class. So I'm just like, this is stressful.
Oh,
But yeah, I
sorry
mean,
about that.
yeah, and it's just more like in terms of figuring out like, okay, so I'll focus right here, and then I'll spend the other hours maybe tomorrow at this time. So sorry, I'm like all over the place.
Okay, understand. Well, let me know if you have questions or need some help or things like that. The recordings are always going to go up. If I don't put it up tonight, usually tomorrow morning. So in case if you need to spend time in the other class versus this class, then you can do that. But if they're both on Zoom, you can be on two systems and multitask at the same time. But I know that can be very challenging. So
Yeah. See, and I'm like, I really like this class too. I kind of also did have a question about the lab that we did. Um, you remember my problem with the last
project.
final project and how I kept saying the issue of that it wasn't fully, oh my gosh, I forgot the wording, but pretty much that because it was calling, was there like, because I don't know, I think I did the same thing because it would not, in the last problem, problem 4 in the lab, I could not get it to fully work. So I'm just like, is that potentially something we could discuss again? Or
Yeah, I can come back to that in the next lab. But I think what it is it could be that you're creating objects that's inaccessible in the other classes. Um, if they're intertwining, you got to make sure that the objects are and the attributes are accessible. But yeah, I can go over that particular question. I know I didn't finish mine. I know I was writing it. And so yeah, I can come back to that the next time on Wednesday. Okay,
thank you.
you're welcome. All right. Hi everyone. I hope you're doing okay. We are going to do benchmark and profiling, well, a little bit of it today. And then for the next session on Wednesday, I think I'm going to release a virtual machine. I'm going to try to find to see if I can put it up on it, or the instruction for you to do that. But if you have Linux, you can use a Raspberry Pi, or if you have a virtual machine that's Linux already, that will be great. But if you have Mac OS, you can actually simulate it with Mac OS, running the application. It's just Windows. There are certain things in Windows that we cannot achieve, because the tools are written for Unix or Linux system, and Mac OS is Linux based. So there are some similarity. There's some slight different in the tools, but we can touch on that. Okay. All right. So today we're gonna officially do chapter 1 in the textbook. I released the notes, the assignment. I'm still finalizing the lab, and so I will put that up tomorrow or so, so that way you can prepare for the lab. And we're just gonna do 2-3 type of profiling, and some of it is graphical user interface, so it's pretty easy. Okay, so I'm gonna go ahead and go into screen share. Do you have any question before we start, Michelle?
Oh, no. Oh, am I on? You can hear me?
Okay. Yep. We're good, right? Yeah, let me know if you have questions anytime. Okay, so if you look at our class, the second modules, you can find the details there. Everything is posted except for the last one, which we're going to do KCacheGrind, DIS module, and memory profiling. The target for this particular chapter is to really allow you to see how efficient your program would be. And in general, you can do this with C language, C-based language. Python, however, have many different type of options in how you can look at the application and see how the performance of your application would be. And the goal is to build some kind of evaluation or assessment over many different versions or iteration of your program. There are many different type of benchmarking and profiling for the system. You can benchmark CPU, hardware, but we are looking at software and how we can look at our loops and our functions and our class and the program within. So the notes, you can find that here. You can download that if you don't have the textbook. Generally, it's going to be very close to the first chapter. And then the lecture and the videos will go up here after today. For our assignment today, you are going to need these files, and these files came with the textbook. I officially subscribe to PACT, and so you can also find their GitHub repository for the code. I believe that you can publicly find that, but I use PACT and I was able to download it. So we are going to evaluate the test simul and a simul.py. So you want to download these programs so you can see how they're written. And then we're going to use those programs to test. And so you can have a general idea on how to approach it with your own programs. The assignments, you can find that in the document below, and then I will go through this now together with you. So, in the chapter, we will start with defining profiling and profiler. This is chapter 1 of the text. So profiling is a way that we can look at the resource intensive part of the application, especially when you're dealing with an application that, let's say, that has recursion or something that would require a lot of RAM and a lot of CPU power. So the two main area that we strive for is efficiency is going to be the reduction in memory usage and the reduction in processing. So the program that would make it efficient is that we wanted to see how our functions are written. So that way we can improve our functions and improve our containers. So that way our program will be faster and better. So profiling is just a way that you can look at the most resource intensive part of your application. And the profiler is used to really monitor each of the function and the tasks that it needs or things that it needs to execute. So when you run the profiling tools, what that will do is it's going to allow you to monitor your program performance from one version to the next version. So we are introducing the tools in this week, and Python provides some tool that will find bottleneck. And when you hear the term bottleneck, what that really means is if it boils down to one part of the application that's going to really be hanging up the rest of the task, that's going to be the bottleneck. So we want to be able to build some kind of measurement using the metrics out of these tools. And so I provided here a link to the documentation for profilers. And if you take a look at the documentation, it goes over the details of the tools and how to look at the limitation and the calibration. So the area that we're going to look at is going to be cProfile. And this is going to give you a way to really assess statistically your Python program. And so what it's using is there is a functionality in Linux that was incorporated. It's called Time It. And what this will do is it's going to give you the assessment in how your program is performed based on the time that it's executing certain functions. So we can really take a look at the milliseconds that is used to really execute a specific task. And so if you have, let's say 20 functions defined in your program, we can evaluate the time that is needed for each of those functions and then the overall time for your program. So the manual included some of the general instructions, and as you can see here, here's the example. So to start using cProfile, you're gonna have to import in the module. And keep in mind that if you're using an IDE, you need to bring that in and link it with your IDE. Because if you don't, your IDE will not know where to find it. So anytime that you are using a module, so I'm going to pull up my Tawny real quick because I'm using Tawny. So here's the test symbol program, right? And so if I wanted to use any kind of module that's external, that's, that I need to bring in, what I will need to do is on Tawny, there's an option under the tools called plugins. And if you're using idle, you will have similar feature. And so in idle, you can simply say import, right? And if it throws an error, that means it cannot locate it. So we need to really install it in order to use it. So if you can find a lot of the modules by either searching in the existing, or you can find the packages that you need. So in the case that if we want to use like, if we're looking for something that would relate it to benchmark, right? If you wanted to obtain this package, you would search for it. And then if it's not installed yet, you can click install and it will bring that in. And this is on Tawny. The other IDE are going to be similar, where you would need to add the plugins in order for that to work. Okay. So keep in mind that you have to do that. So for here, what they're doing is they're showing you that they have a program, and they're going to use the profiling tool to really determine the primitive calls, how long that's going to take, okay, and for the overall function call. So when your interpreter, when it goes through line by line and when it gets to your function, when you have a function call, it's going to be able to read that section of your function definition and it's going to execute. What this will do is that it's going to really it's going to call continuously throughout the program, and it's going to put together the amount of time that's needed to call those functions. And so you can evaluate the time that's needed for your function here. And what our goal is to really make it efficient, where it would reduce the time so our application will be fast. Okay. So in analysis of, if you're looking at application analysis, this is an area that an analyst would need to explore, right? So after the developer and the analyst will work together at the end before you beta the program, you want to take a look at how you can improve your program, how you can debug it, how you can make it efficient. So here it shows you an example of that. So in this section, it talks about cProfile, and cProfile, it uses C extension, and it is suitable for long running programs. So if you have a lengthy program, cProfile is suitable for that. There's also a profile module. This is used, it's imitated by the cProfile, but it adds on overhead when it profiled the program. So what we can do is we can take a look at how we can utilize multiple tools to be able to give you the outcome that you need. So the profiler module, it's really designed to execute the program, not for benchmarking purposes, but to really look at, to create a profile for your program, meaning a snapshot of your program on how it's ran at a certain period of time. And then from that, what we can do is we can build out different iterations of the program to improve the performance. So benchmark is really a script that you write to assess the overall execution of the time and the application. So before you benchmark, you need to create that snapshot, that profile for your program. So it's like this, you know, just like how you're doing chores. The first time you do it, it's gonna be, you know, average to slow. The second time you do it, you're gonna improve some of the process, so that way you will make it a little faster, save you time and resource. And the third time and the fourth time it will be better. So what will happen is when we use the profiler, it's gonna give us an idea or a vision on how our program is performing. And then we will write the script to really look at the overall execution and the improvement of the program. Okay, so what you see is basically the definition of that. So in the first question, it asks you, describe profiling and a profiler in the application development. So profiling is a technique to pinpoint the most resource extensive spot of your application, right? Like we talked about recursion, and if you have recursive function, that we will focus in a certain area that's going to require processor and RAM heavily. Then profiler is a program that runs an application and monitors how long each function would take. So it's going to evaluate each of the function. As you see, it will look at the function call and the time that's needed for that function call. Okay, so these are from your notes and also your textbook. You can find this on page 1 of your note. So for question 2, it asks you to identify the Python profilers and describe their purposes. So cProfile, we said that it's recommended for most users. It's reasonable with overhead, but mainly it is suitable for long-running program, for lengthy programs. And then regular profile is a module that is imitated by cProfile, which adds significant overhead to the profile programs. So what you want is you want to use these two together, cProfile and profile module. What profile can give you is the statistic that would describe how often and how long certain part of the program is executed. So in recursive function, you know that the function is calling itself. So it's going to give you the statistic on how often that function is calling itself. These statistics can be formatted into a reports using pstats. So you can take a module such as pstat and be able to look at the report. And in analysis, that's important. We wanted to really look at the numbers to see how far it has changed from the original version to the improved version. Okay. So cProfile and profile information, you can find this. You can find these information on the first part of your notes. The reason why I'm doing this to go over, I know everything is in the notes in the book, is I hope that when you put down the answer, you would remember And as you write it down, you would think about how you would apply it. So in the future, for your project, you will be required to assess a specific program that we write. And starting this week for the lab, we are going to look at how we would profile in different areas and then how we can improve the program. So this type of knowledge is usually being brought to you in the upper division classes. I want to give you this, so as some of you are doing this, maybe in your career, or if you're transferring to university, you'll be ready. Okay, because profiling usually this is where, and benchmarking this, they touch on this when you get the upper division classes in computer science. Okay, any question with number 1 or 2? Okay, so keep in mind that cProfile is good for lengthy program. Profile would be used with cProfile as it imitated by cProfile. And we can obtain statistic for profile. And these are the profilers. Okay. And then, and you can find this on page 1. So in the design, before you start assessing at the beginning, when you start writing your program, a lot of my students, they just write to solve a problem, but sometimes, you know, we have to think about the algorithm that we're implementing to make sure that our program works, but also efficient. So the design of the program can change, and that would require rewrite. So in the case where if we start with a simple program and we want to improve it, we might need to rewrite that program. To really optimize your program, your code, there are 3 things that you need to focus on. The first part, like most students that you would see, they just want to make a program to work, right? We come up with the solution to solve a problem through software. That's why we write program. So, and that solution must work. So first we need to make it run. And the working state of the software, and we want to make sure that it actually produces the correct, accurate result. So that's usually the beginning phase. And this gives you a better understanding of how we would address certain problem in the program in the earlier stage. And so when you take a problem, you want to evaluate that problem and break it down into the subtasks. And by each of the subtasks is how you would write instructions or code. So first we make it run, then we improve it, then we make it right. So the second part is to make sure that the design of the program is good. And we should do this before we improve or we optimize. So the suggestion is that we would separate the application into independent cohesive units for easier maintenance. And we talked about modular approach in 30A and also last week, where if you organize everything into subunits and you combine those units into an overall larger program, it is a lot easier for you to fix the part that is wrong. So when you make it right is when you look at the units of your program and you would maintain it, you would fix it to make sure that it's correct. So after you design and make it work, after you make sure that it's accurately producing, then we want to improve the speed, make it fast. So once the program is working well and it's structured, we want to improve the performance. So I say this in most of the programming classes that I teach. When you write your program, it's all about using and optimizing your memory usage. So when you create a list or an array, right, you're really cutting up a piece of the memory and be able to store it. Okay. So the question is, if you have an app where you're constantly downloading information from an API, it doesn't seem like there's anything one can do to improve that downloading process. So if that app is really updating, so yes, you can, right? Let's think about that process, Michelle. So let's say that if I have an app and I would require the user to really download updates constantly, right? We think about the sub process in that. Notify the user, wait for the user to click. Once the user could click, there's a function that's going to connect to a server that's going to be downloading the files that it needs. Then we want to install those files and then keep on going, right? So how can we streamline that and improve the performance? First, we need to take a look at, can we combine the functionality and automate some of that? Do we require the user for a certain part? So in the case where if you want to implement the API and authentication, that you would have the user to authenticate every time, would that be more efficient to really require that process, or there is something that's running in the background? So if it's just a firmware updates for that device with the app, then we can probably push that and automate that and synchronize it. But in the case where it is a session based, then we want to be able to think about when the user logs in, it should be automating in the background and be running that. Then we have to think about how we're using your data. How is the data structured? Is it pulling, and how we're storing it? Is it storing it locally, or are we using everything cloud-based? So optimizing can be in many different areas in how we're using our data and where our data is coming from and how it's organized in the program. But mainly we want to look at how memory is used, okay? How functions are called, how classes are created, how objects are used. So you can still have the same task being performed continuously, but in a way where you organize your program and structured your objects and attributes, that makes a difference in how your performance would be. Okay. So we can really map out, and we will look at some of the tools that it actually diagrams out everything for you. And you can think about how you can omit something, combine something, or improve the overall program. Okay. Now, if you're bringing in third-party API, in that case, when you're introducing third-party API, right, there's not a lot we can do, especially with using somebody else's API. But we can think about how that API is incorporating with our application, the way that we use it, okay? Like for the session call, for authentication keys, how we generate that public key for that session and be able to utilize it, right? And then, how that key is being reused and so on. So there are many different aspects in how you want to execute and the purpose of your program, along with what you're using externally. Okay, so for the third question in our assignment, as you can see, you can put those things down. In application design, what are the 3 approaches in optimizing your codes? We want to make it run. We want to make it right. We want to make it fast. So first we got to get it working. Then we want to make sure that it's accurate and it's working and it's good, right? And then we can go to the next few iterations by improving the performance. Something that you can think about is how you're using loops, like for loop, right? Or nested loops, okay? Because as you loop, right, the processor is going to require to execute for each loop because it's logic, right? If it's true, it's, let's say that if I'm using a while loop, it's going to keep running as long as the logic is true. So then I can think about how that plays into the big picture on how my processes would be and my performance of my program. So if you have a functions and you have many nested loop within, you need to think about how you can optimize that. Okay. And you will see on how we use these profiler this week. Any questions regarding 3? Okay, so you can find that here on page 1 of your notes. So in the text, it gives you an example, and I wanted to give you the code so you can follow along, right? The program that they created is a simulator, and it's simulate particles. It's mapping out how the particles would move from one location to another, and it would use coordinates X, Y to really show how particles is moving from on screen. So that's just a general information about the program, and this can be used for like science, you know, for research, for testing purposes, and so on. Okay. So the example that they use is it's going to show something like this on how particles is moving across. And so what they did was they started with creating a class, and in that they would define the member functions. So we would have X, Y, and then for the angle. And then they have a second class called particle simulator. And in that, right, here they would have what's called the evolve function. And then for the time, and they would then implement the algorithm. So how are they going to be able to move that particle across screen is it's going to use the function in the second class. Then inside the evolve function, as you see, we have a nested for loop. Okay. And this is going to iterate and give you what you see on screen as the particle movement. Okay. And it calculates the displacement. So it's pretty straightforward in most cases. And so when we look at the application, we take a look at how the functions are defined in each class and how the loops are used in the function. And then for this program to work, we need to use matplotlib, which allows you to plot the actual particle movement. So it's using another module to be able to animate your particle movement. Okay, so they have a function called visualize, and this function is used to simulate the particle with the X and the Y coordinates, and it's going to plot it. Okay, so there is already a library that's written for plot. Then in order for that to work, then we would then need to do a plot show. And so that would make it animated. And then they have another function called animate. And this is going to call the evolve function, right, from earlier, from what you saw. And then it's going to be able to animate that. And here is the plot that show. Okay. So at the end, what you would see is you would see that the functions that they use, we will evaluate how the application is running by looking at how the functions are written in the program. Okay. So I put the programs into Canvas. Let me see here. Okay, so this is the entire program that was included, and that's broken up into different parts that you see. Okay, and you notice down here is where we would add in the script for benchmarking. Okay, so we would benchmark the heavy duty area, which is evolve. That's where the algorithm lies. And then there's another function. We're going to use time it, and we're going to use the output from benchmark to really show the result. Okay, so these are the added script to the program that will allow us to look at the performance of the program. Also, right above it here is you would see another function called test evolve. And in this, we'll talk a little bit about this shortly, but we would use the assert statement. So what we will do is we would give it a certain value, right? Like automate the hard coding piece of this to really enter the value and see how the function, how the processes are being handled by using those values. So the way that you can test a function is to use the assert, and what you do is you're going to inject into the function the values and then see how it's going to perform and give you the overall time evaluation. Okay. So here it talks about writing the benchmark section. So the first step in writing the test and benchmark is to test the accuracy of the results produced. So you cannot benchmark and test your program until your program is accurate. It's producing the right result. We would then either rewrite the code multiple times to make sure that it is optimized, improved. And we want to implement throughout different iterations and make sure that it's accurate. Okay. So as you saw, we want to use separate functions for each of the unit applications. So if you want to test the evolve function, you want to write the function to test it. Okay. And so if we want to test visualize, we would write the function to test the visualization. We test the evolve, okay? And then we also assert for the equal. Okay, so as you can see, these are subunits to be able to evaluate each of the function that would require a lot of resources in your program. And down here, it talks about benchmarking. So what we want to do is we want to have a representation of the case to assess the runtime of the application. Now, unlike C++ and Java, Python uses interpreter. That means that it reads line by line, right? Java and C++, it compile the entire program first, right? And then it's going to execute. Interpreter in Python execute line by line. So what we will do is we can profile it line by line, and we can also benchmark it to really look at the runtime based on our function line by line. So the component that's needed in benchmarking is called a time command. And when you use this, it's going to give you the evaluation of 3 areas. real time spent to run the processes, the cumulative time spent by all the CPU during the computation, because you know that we're using multi-core now. So we can use user metrics to measure CPU performance. And then the third column that it's going to give you is sys. That will be the time spent for all the CPU for the system related tasks, such as dividing up the memory for containers and so on. And it says here that benchmark should have been long enough, the execution time, so that the setup and teardown of the process is small compared to the execution time. So it should be less than the execution time. So let's take a look at the requirement for our assignments. For number 4, it asks you to define benchmark or benchmarking, describe the purposes of benchmark and how it's used in the application development. So benchmark is a simple and representative use case that can be run to assess the running time of the application. It is useful to keep score of how fast your program is with each new version that we implement. So if you're looking at version 1.1 compared to 1.2, right, how is that improved? It's also a simple way to benchmark using Unix time command, which measure execution time for arbitrary process. So we would use Unix time command to evaluate how fast it is executing. Any question? So going back to all the applications that you've written, whether it's for networking or for, sales, finance, whatever, right? You have a program somewhere that you wrote in other classes. And so like 30A or 30B or another class, okay? What you can do is from here on out, you can say, okay, let's take a look at how fast that is, right? So in the case that if you're writing program for IoT devices, right, we want to make sure that it's responsive because no customer will wait a long time for the application to run, even though it's working. You've seen these, you buy some device, maybe because it's affordable, but then there's some functionality in the software that doesn't always is to your liking. It's slow, it connects very slow. It's not producing the accurate result. It's not real time. So for IoT devices, we want to make sure it's real time, right? For networking, we want to be closest to real time as possible. So this is going to give you the overall understanding on how to really take a look at what you wrote and improve it. Questions? So this section, you can find benchmark on page 5, going to page 6, okay, of your notes. So in the text, it talks about how timeit would work directly with IPython, okay? And IPython is basically a shell that allows you to interact with the interpreter. It uses what's called the magic command. So whenever you see the statement that has the percentage symbol in front of it, that will allow you to use what they call the magic commands. And if you use the double percentage symbol, that is the cell magics command. And when you install Anaconda, which we will do later, you are able to access IPython via Anaconda package. So the time it module is just, it's gonna run a section of code that's gonna loop so many times. And when it repeats, the default is 3 times, but you can specify how many times you want it to run. Okay. And what that can do is it's gonna give you, out of those times, there are times, so let's say that we run it 5 times and we're gonna see the difference in that. So it's gonna give you, right, the outcome that's gonna look like this. Okay. So in command line, if you invoke time it, and you can pass a certain option for it to iterate so many times, what that will do, it's going to tell you the best time that is used for the loop. Okay. Now, in analysis for application, you know, if you've taken other programming courses, we don't evaluate the application based on the best time as the outcome, right? We look at the worst case scenario. So we would have an understanding of how long it would take. So out of the 3 times that it loops, right, this is what we would see. The best of 3 is 782 milliseconds per loop. Okay. And so you can also run multiple loops. So in the case, let's say that I have a for loop and it's going to go 10 times, then it's going to tell me out of the 3 tries that runs the 10 loops, it's 826 milliseconds per loop. And so on. Okay. So this is something that we can use, and it came from the Unix architecture, the Unix platform in the past. And you can use IPython with time it. We will run it on Windows for some part of our exercise today, and you will see. So next, I'm going to talk about pytest. So pytest is a framework, and we can use it to evaluate our application. So for large applications, okay, and libraries, let's say you write libraries, people do it all the time, right? If you work with Raspberry Pi, you took my Raspberry Pi class, we saw already. There are tons and tons of libraries that you can use for sound, for graphics, for things like that. So how can we benchmark those? We can use a framework like pytest, okay? And pytest is a framework, but you can also incorporate a plugin, which is a module that works with the framework called pytest benchmark, okay? And if you click this link, you would find the information for pytest. So it tells you first line, pytest framework makes it easy to write small readable tests that scale to support complex functional testing for application and libraries. So it is a small script that will work with larger applications. Okay, this is pre-written for you. And so if you want to learn how to get started, go through the get started and how to guides, right? And then there are documentation that you can read. You can also go to the help function in your IDE if you install the module or the package. So for number 5, we would answer question number 5. What should you use to benchmark large Python applications or library? We would use the pytest framework and pytest benchmark plugins. I forgot the hyphen there. Okay. Any question? So we have a little hands-on for this shortly after these questions. So here we would have, we would need to download and install PyTest framework. And then we also need to install the plugin. Okay. So if you're using like Tawny, like your IDE, you would then go to here, and then you can type in pytest, right? And then if you want, you can install. Okay. But we are going to do it in our virtual environment for Python. So if you want to use your IDE, that's how you would bring in your packages and modules. Okay. Let me come back to this. Any questions? All right. So for the next part, we are going to test these concepts, right? I want you to use, and we're able to use Windows environment in order to do this. But for the other tools that we are going to use for the lab, which is for memory profiling and the other areas, we would have to use a Linux-based system. Okay, because even if you try to run it in the Python virtual environment on Windows, it just doesn't have the capability to give you the things that's needed because it's written for Linux environment. So any questions regarding 4 and 5 before we start 6? Okay. So in order for 6 to fully work, you need to download those files that I put, the Python file. Those are for chapter 1. So when you take a look at the code that's described in the notes and also in the textbook, right? That's what the programs that they've written for the chapter, they're those. Okay. So keep in mind that I'm writing these instructions for Windows 10, right? Similarly, you can do a lot of the stuff in Linux or Mac OS, like, you know, some of the commands are the same, some of the commands are different, but in general, it's pretty close. Okay. And yes.
For step 6G, if
Mhm.
we don't have a scripts directory, do we just make one?
Yes. It should be there. If you enable your virtual environment, scripts automatically get put in there. If you do this,
I was using
yeah.
Ubuntu, and it's
Oh,
not-
okay. Yeah. So yeah, if you don't have the scripts, then you would let me pull up the instruction for you real quick before we start that. So you can just search for Python virtual environment, and then there's steps for Ubuntu. Okay. So it's slightly different from Windows to Linux. How you activate it. Okay. So you can find the documentation. I think we did this in the past for another class. Let me see if I can find Linux. It should have like the Debian for it. Yeah. So for the difference between the Windows side, yeah, you have the scripts when you activate it here. And then for the Mac OS and the Linux side, you would do whatever the name of your environment is, you would do it here. It uses bin. So you can point back to bin. You don't have to create that. You can just point back to the directory that would have the Python packages. okay? So when you install the Python virtual environment, what it does is it's gonna bring in the Python packages to that virtual directory, and then it will be able to access it. So it's contained in that folder. So for the Linux side, you can check out the bin folder or directory. Okay, so for 6, download the Python files. Then I'm gonna use Windows, so we are gonna do CMD to start for command prompt. Okay. So here's my command prompt, and then the next step is that we are going to go to our desktop and we are going to make a folder. Keep in mind that we always want to have a working directory, any kind of environment you work in, whether it's Linux or Windows, you want to organize your, that's why IDE, they would have a project folder, and then inside it, they would put, you know, all your source code and all of that. So manually, we would need to go ahead and do CD desktop. And that will move me into the desktop, right, directory, or now I'm navigating to my Windows desktop. So that is step 6B. Then we are going to make a folder on the desktop. And if you don't use desktop, you can put it in another directory, that's fine. But I just want to keep it there so you can find it. So we can make a directory called test1. MKDIR. I'm going to call it test2 because I already have a test1 when I wrote it. Okay. Then once you have your folder created, we are going to move into that folder. So we are going to do CD test. In your case, that will be test1, but I'm going to use test2. So as you look, you would see the path of your folders or your directory. Okay. Then what we'll do next is we are going to enable the Python virtual environment. Okay. And I put the link here for those of you who are using Mac OS and Linux. So you need to make your folder and all of that similarly to Windows. Then we are going to do a Python 3-m V&V. This is going to be for virtual environment, and this is how you are going to name your directory that's going to contain the Python virtual environment, a folder. Okay, so whatever you name that here, it's going to create the virtual environment within that folder. Okay. So I'm going to go ahead and copy this. And I'm going to issue that here. It's going to take a couple seconds for it to activate, or I'm sorry, to create. And then, so what we're doing is we are going to put the virtual environment in a folder inside another folder. Okay, so if I look at my desktop, and then I'm going to go ahead and look at test2. There it is, right? But it's not usable yet until we activate it. So, and this is good for like testing stuff. So you don't use your native system for a lot of stuff that you want to test. You can just put it in a directory and then run it with that directory. Okay. Then we need to navigate to the actual subfolder that contain the virtual environment. So we need to do a CD test1 env. So now I'm inside that. Now, if you look at your directory, right? And keep like what you heard what Michelle said, right? On the Windows side, you would see the scripts here. On the Linux side, you would see the bin. Okay. So we want to activate it now by going into the script folder, and then you can use activate.bat or just activate. On the Python 3, you don't have to use the .bat, but you can. So we would then need to move into the scripts folder, which contains your Python packages, and then activate. And you can simply activate on the outside too, but I wanted scripts. And then we want to say activate. Now, once you're activated, you are going to notice that there's a parentheses in the front, and it tells you that's the virtual environment subdirectory. Okay, you're in it and you're using Python virtual environment there. Okay, before, see how it doesn't have it? Now we have it. Question?
Professor?
Yes.
So on, I believe it's step, which step? I think it was step 3 that I'm stuck on, where it says step E, where my command prompt says Python was not found, run without arguments to install. So it's basically telling me to install something from the Microsoft Store after I do Python 3-m env test env.
Okay, so it's asking you to install Python.
Mm-hmm.
Yeah, that means it cannot find Python 3. You might have Python 2 installed, or it's not linked somehow.
Mm-hmm.
So all you have to do is you can install it directly using command prompt, or you can download it. So you can go to python.org, and then you can go to downloads, and then you can download here. Okay.
I do have idle on my desktop, so I believe I have downloaded Python 3 before for 30A.
Yeah. So can you share your screen? I want to see your output real quick.
Yeah.
Is that a path environmental situation?
So it says Python was not found, run without arguments to install from the Microsoft Store, to disable the shortcut from settings, manage app execution alias. Yeah, so it's not able to find the Python 3. What was that, Michelle?
I tried it on my Windows. I have the same thing, and I also have idle. I just wonder if it's a path environmental. It's not in my path.
Yeah, because your system, your environment variable was not set somehow when you first installed it. So that's why it's not able to link it. Okay, give me 1 second. Let me give you the command on how to install that. So if you download and install it again, let me show you. Can you? Okay. Okay.
Share?
Yeah.
Okay.
Okay. So if you read their documentation, I think if you installed it before, what happened is you didn't have it linked to your system environment path. So this is, and you can download and install the latest version. So when you download it and install again, you would then need to make sure that you select this option right here, add the latest version to path. Okay, because what happened is if you install without this checked, it's not going to link it to the system environment variable, you can manually go in and set it. This is, you know, it automates it for Linux systems and Mac OS, but on the Windows side, you have to make sure that you customize it. So make sure that this is checked. And then what it will do is if the 3.9 is going to be linking to that path. Yeah, it happens quite a bit. So you can just download and install and then make sure that you check this option. Okay.
Okay. Thank you.
You're welcome. And I hope that works for you. Other questions? Okay, so for the rest, right, once you are activated, what you will do is you will need to make sure that your Python application, your code, your script is in the folder that you are testing it with. Okay, so if you downloaded, you know, the test simul, this is what we're going to be using, right? And we are going to be using these programs. Make sure that you put them inside the directory, which is your script folder. Okay. So I'm going to go ahead and do that. So here are my files. I'm going to go ahead and copy, and you can find yours on downloads. And you can move it through command line. You don't have to use something like this. So here you can see that these are my Python packages. So I'm just going to simply put those there. You can have it on the downloads. You just got to make sure that you put the full path when you write in that script. Okay, because in the next few steps, you can say C desktop, you know, down, or C drive downloads folder, and so on. So if your full path doesn't work, then it's not going to be able to find the file. So just to minimize all the extra stuff, I just simply copy and paste the file over. So I put it into my scripts folder, and if you're using Linux, you can throw it into a bin. Because Python 3 is under bin. All right. Then what we're going to do is we are going to, now that we're in that virtual environment, we are going to install all the packages that we need in that virtual environment. Okay, so that way it will all work. So we are going to do a pip3 install pytest. Oops. Sorry. So copy. And this will take about a few seconds for it to go. It needs to pull the packages and put it into your virtual environment. All depends on connection and everything else too. Okay, there it goes. So when you started seeing the status, right, for the plugin, that it's pulling that from wheel, and then it's putting in the packages. So you would see that there, and it will tell me that I'm using a dated pip version. That's okay. And it tells me that I can do a pip upgrade there, but that's fine right now. Okay, so now I have the pytest in the scripts folder. Then what I'm going to do next is I'm going to also, because remember that the particle simulator that they wrote uses matplotlib. If you don't install this package, it's going to throw an error when you test it, because it's not able to use some of the functions that is pulled from that particular library. So we are going to go ahead and so whatever the packages that you are using in your program, make sure that those are available as well for the testing purposes, because it's testing the function. And if that function is not found from a library, it's not going to like it's going to complain. Okay, Python's going to complain. So we are going to go ahead and put that there. And then we are going to pull matplotlib down. Okay, and then it's finished. So I installed 2 packages now. And then we are going to do the next one, which is the benchmark. So we are going to put the plugin now for the pytest. So this is the package for the framework, and this is going to be the plugin. Okay, I already installed it in the past, so it tells me that it's already satisfied, but you should have the status. So what it is a zip file, it's gonna pull it down and then it's gonna unpack it. Okay. Question. So here, what we have now is we have the pytest, we have the matplotlib, and we have the pytest benchmark. So once you have the packages in there, what we will do is we are going to run the framework. Okay. First, we are going to run the framework, and then we are going to profile using cProfiler. And the way that you use the cProfiler is that you would say Python-m, right? cProfile, and then the file name, the program name, right? The Python program that we would test. So next, I'm going to go ahead and run pytest. And you just have to be a little patient that it's going to go through. And it tells me, right? See, it's using the plugin benchmark. So without benchmark, it's not going to be able to achieve that. And I had put the test symbol because that, remember inside that script, it has the assert and it's going to use the test evolve. So these functions are already pre-written. So with the benchmark, it simply uses that script. So here it would tell me that this is the iterations and it's using these scripts or the sections of your program to be able to test. So there's the minimum time, the maximum time, and remember this is in millisecond, the mean, the standard, the median, and so on. So this gives us the numerical understanding of how our performance right now as the program was given to us. Okay. And then at the end, it tells me that one passed in 2.92 seconds. So statistically, it shows you what that is equal in milliseconds, right? We can see the values.
Question?
Yes.
So it automatically knows to test all 3 files, or does it just knows to test where the algorithm is? How does that?
So if you take a look at the program here, right? it does this. It runs this and it's assert the value here, right? This was added and then it runs this. So in the simul, right, it's gonna run this and this concurrently because this module contains the definition for the test eval, right? And it's gonna assert the value from F equal. And then over here, it also uses test eval here. So as you call, right? So these two work together. So the way that you would write your program is number one, right? You would have a program that has all the functions that you need. Number two, you would want to have some kind of benchmark script to be able to see how it's benchmark here, to call the benchmark for that simulator or that application.
But what happens with the Taylor script?
Yeah, Taylor is not used in this one. I just have you put it in there just for convenient purposes, but yeah, just the two. Yeah, we'll talk about the Taylor one. So here, since you asked. So this is a different program. This is for factorial. And what you can do is you can also benchmark that too. So what they did was they wrote the algorithm for a different program, which is come later in the chapter. And then they benchmark it by passing in a certain value here. Okay, this is for testing memory down the line by line in memory profiler. Okay, so if you want to run that, you can, but on this one, we didn't really do a search, so we would use a different tool for that. Okay, so we run the pytest. You saw that. I just need you to take a screen capture. So what this exercise does is it shows you the procedure on how to place your program into a Python virtual environment, run the framework along with the plugin, right, to be able to benchmark your program. Okay. Then now we are going to profile. So in the next step, we are going to run this. We are going to use the cProfile and we are going to run the specific, we're going to create the profile for that particular file. Okay. So you are going to get tons of information, lots and lots, and it's going to go for a while. Okay. Now on the, keep in mind that this is also processor dependent. So in the case that if you're using a very old system, it will take a while. Okay, but now I know that all the modern processor, you're able to have multi-core, and so simultaneously they are going to work. So what it's doing is it's building the profile, it's testing, right, your methods, and it's looking at your objects for that program. Remember the simulator, it has class, it has all of these things built in. So, and then looking at where all of these, the values are placed, the container, and so on. So once we have that, we have we created a profile for our Python program using cProfiler or cProfile profiler. Okay. So let me scroll up so you can see. And there are various, you would see different values, right? Sorry, my Zoom is just in the way. So let me scroll all the way up. So at the top, you would see the columns, right? The number of calls, the total time per call, that's the time per call, cumulative time, time per call, and then the file. Here, it will tell you the number of function calls and the number of primitive calls and how long that would take. Okay. So what it did was it organized, right, the outcome numerical values that you can evaluate as time, and it also identify, right, the line for the function, right, as it runs through. So the overall function call, you would see that at the top, and the primitive calls, you would see that here, and the time for those would be here. So if you're debugging and if you're looking at the specific area, let's say this one, right? And then you do see some outlier where it would be resource intensive. So you would then look at those. Okay. And so on. So to really answer the questions, you can scroll to the top and you would be able to find the number of function calls that was used to create the profile for that program. Right, you would see the primitive calls and the function calls. Now, if you want to sort by a specific metric, you can put in the option S to sort. So if we're looking at total time, then we can do total time on this. And all of this you can find in their documentation, right? In the case where, you know, months and years from now, you said, oh, I want to do this, and I don't have the notes from the class anymore, then I can go to the documentation and be able to find it. Sorry, I'm just gonna pull down. So now it's just gonna rerun it, but instead of giving you like what the default output would be, it would give you the sort based on total time. Okay, so you can organize, right, by just sorting the output for your profiler. Now, what good is it if we're not able to report it? So I got, does that mean relative to your number of function calls and did 3.18, sir? Yeah, so like I said, it's processor dependent, right, Michelle? So your system versus my system is, we have two different systems, right? We have different processors, we have different amount of RAM, right? And so when you run it across multiple systems, you're gonna see that they are different. So my suggestion would be, let's say that you are writing an application for the same type of system, like let's say a portable device that use AMD processor, for example. That will be standardized because then you would run it from one device to the next. It has the same exact amount of memory, the same exact processor, so that would be more accurate. But if you're building an application to use on Windows PC, well, usually you would say there's a minimum requirement for the processor, right? Like an Intel i5, 8th generation and up. So if somebody has an i9, that is a lot faster than the older generation i5, you're going to see that the outcome for the calls are going to be quicker. Okay, so there is some variance that would be hardware costs, you see,
I
because
guess-
it's, yeah.
Doesn't it seem like it's less efficient if you have to run more function calls?
Yeah, sure. But at the same time, so when we look at analysis, okay, the more doesn't mean that it's less efficient. I see what you're saying. But what you want is when you want to close down the gap for your margin of error, you want to have more. So in analysis or in research, what we want is we want to have a larger population in order to really look at the accuracy of our outcome. So when it runs more, you're going to have more data, and then it's able to derive the standard deviation based on that data. So in between like 51,000, or I'm sorry, 479,000 compared to 500 and let's say 12,000, overall, not a huge difference. Okay. But when you look at the seconds, right, based on what you put in the chat, that is of significance. Okay, so let's scroll up. So this is my second round running with total time sort. Sorry, it's a lot. So here's my data, right? And look at the seconds. So we have to really consider like hardware as well when we look at that. But ideally, if you test this on the same type of system, you would see how consistent that would be. So when we're looking at different type of system, how can we say that, you know, what would be like the average, right? So we can say that, okay, so on my system, it's 1.5 seconds. On your system, it's 3.18 seconds. Okay. So there is a range in between, and then we have to take a look at the spec on why is that going to be different. So in different systems, when you say install this application for the user to use, they would expect to be, you know, the length of time that's expected for this particular application would be roughly around what, 1 to 3 seconds. So we have a general idea based on that profile. Okay, other questions? Oh, sorry, it's always coming up when I hover over it. Here. So next is we are going to go ahead and output a file. And in this file is going to give us the result. Okay. And in the textbook, it talks about you can parse this file into text, or you can convert the file into like CSV or some kind of list. So you can, you know, put together a data analysis report for your program. But I stopped before parsing because I just want to spend a little bit of time just getting back to the last part of the chapter instead of, you know, because I have about 30 minutes left. So on this one, when you get to that step here, we are gonna go ahead and output it, and the file name is prof.out, and option O is for file output. And so if we type in dir, okay, we would be able to find that particular file right here. And if you're using Linux, it's just ls for list. So with that, we would then have a file of our result, and then we can use this file for analysis. And as you run this, you can see that it created these, right? Because they are modules that you're pulling. So it put the dot benchmark and a dot pytest. This is the cache for it.
Question.
Yes.
I'm getting permission denied. I can't put the prof.out file in the bin folder. Where should I?
Oh yeah, because it's system protected. You can probably put it in. Maybe you can output it to home, but you have to put in the path, Michelle. Like the output here, you just gotta make sure that you put in the slashes where you want it to home. You can probably write it as a user. Bin, they created the bin directory to not add any more stuff in there that's not system oriented. So things that are non-packages, things like that won't be able to write. So you can, you can put it onto your desktop, or home directory would probably be fine.
Thanks, it worked.
Okay, let's try that. And then when you're done, after you have your file output, you can deactivate by saying deactivate. And it's going to take you to your regular path. Your regular path there. It's going to remove this. See? And then if you want to exit command prompt, you just type exit and it closes. Questions? Okay. Questions on anything on 7? So with this exercise, we experience cProfiler. We also use pytest. We learn how to sort as the output to a certain column, and you can replace total time with cum time, or whatever you wish to look at when you profile. And then we run the benchmark with the profiler, and we use the Python virtual environment to do that. So for the lab this week, I want to focus on the other tools that we're going to touch on right now. KCacheGrind and memory profiler and line-by-line profiler. They are different tools than what you've seen. So you would start with, the profiler and cProfiler and pytest. And then if you want the graphical user interface, the graph of your program functions and all of that, you can use the tools that will be described in the next part. So after it touches on the framework, right, gives you the example, I give you the experience with that, with a little exercise. It touches on bottlenecks. and how we can look at the modules. Okay. You can access cProfiler in command line. That's the easiest way. You can bring in the module into your IDE, or you can use IPython, which is from Anaconda. And then it shows you how you can do that, and we've done that, okay? And then here it talks about the columns that we looked at. So the number of times it's called, the total time, the cumulative time for the function call, the per call, the file name corresponding to the numbers. KCacheGrind is on page 10. And this is a tool that has graphical user interface. It does the profiling from cProfile. So basically it has cProfile built in. It just has the graphical user interface that would make it easier for you to see instead of a lot of stuff on command line. It does not read the cProfile output file directly. It also able to use the pyprof2 call tree to convert the output to readable format. So what it does, it uses another module to be able to read the output file. Okay, so in the back, it still uses cProfile. And the documentation, this is an application, so you can find that here. Okay, and you can visualize it. So it actually models the data for you. It shows it, it gives you a map of it. So it has these components for you to see. So for question 8 and 9, it asks you to describe the purpose of KCacheGrind in application profiling. It is a graphical user interface that's useful to analyze the profiling output from cProfile using Linux KDE, which is a desktop environment. So it's designed to run on Linux. And it's called graph, is the representation, graphical representation of the relationship between the function calls. So when you have a function calling another function, it will map it. And it will show that as square to represent the functions, and it will have the linking arrow. Okay. And on this, if you took CIS-30E with me, we did a little bit of the, the graph viz. It also works with the dot file, the dot file. So it has that functionality to be able to map things out. And it gives you the visualization with that. So GraphViz, for those of you who didn't learn it yet, it's just a tool that you can create a graph, right? A node to connected to another node, etc. So those are the two things that we want to highlight with KCacheGrind. It is a graphical user interface. It's used to analyze profiler. And it would show you visually the relationship of the functions and how they're called. So that is helpful when you're improving, right, a certain function, or you thinking of rewriting the algorithm of that function. How is that related to another function? So you can visually see that, and you would be able to really identify the other function that you want to improve or change. On the smaller program, it's it's a simple process, but on a larger complex program, you would have lots and lots of functions. So question with KCacheGrind. So earlier you asked about the Taylor program. It was designed to be used with this particular tool. Okay. And so, and if you want to run it, you can also, like earlier, right, Python environment, we can have the output for the Taylor program in cProfile. There's an example of that there. And then you will be able to use the pyprof to call tree. This needs to be installed in order for you to use it. So you can, in command line, you can use KCacheGrind in Linux. Okay, if you try it on Windows environment, it's gonna complain, it's gonna not be happy about it. So so the output of this would look like the screenshot here. Okay, you would have the functions labeled, and then you would have the arrow that map when you have the call. So the example that they use is the taylor.py file. And then on the left, you would see, right, the time evaluation for it. On the right, you would see the relationship of the function. And since it's used cProfiler or cProfile profiler, you would have the same matrix, the columns that would be incorporated. So this gives us the graphical user interface. And the authors of the book, they suggest that you can use gprof2dot. And this is another tool that you can use to graph out the relationship of the of your functions. And it uses the .dot file, which is very similar to what you've seen in GraphViz. Okay, so it just map out the shapes, right, or the objects that will be linking together on that graph. On page 12, you will find line by line profiler, and line profiler is used to go through line by line. For Python, this is useful because we use interpreter, and interpreter reads line by line. It executes line by line. And line profiler is a third-party module, so we would then need to be able to pull it from their repository. And we would need to use a decorator called profile. So the example that's shown here is how you would use it. You would use the decorator, and then you would have the function. And then right below that, it talks about how you can use kernprof, which is a script. And it would be, we can use this to run the simul.py. This is going to allow you to, when you use an option L, that's going to be your line profiler. When you use the option V, that's going to give you the display output, visual. So think of line and visual. So when we use this script to be able to assess our program, we can simply tell it to read line by line and assess it, and then give us the visual output. You can also run this in IPython shell, and you just load it as an extension. You have to use the magic command in IPython, which uses the percentage symbol. So as you can see here, how they put the load, right? The profiler, and then import benchmark. See, it's just a shell, so you have to execute each line. And then you use another magic. Okay. LP run, and so on. So when you get the output from the line profiler, it's going to include these. Because it reads line by line, it's going to give you the line number, the hits, which is the number of times that that line actually is ran, the time, execution time in microseconds, and then the time per hits, the percentage, and the line content. So if you want to dive deeper, you would use the line profiler. So that way it would give you more detail about your program. Okay. So here there's a note about for loop. So when you evaluate the column based on their analysis, the for loop body is about 10 to 20% each. Okay. So earlier we touched a little bit on loop and how that will be cost to the program. So ultimately, what do we really want to achieve in optimization? We really need to think about how we would improve the algorithm that is used. So the example that they provide here, what they did was they originally started with one type of algorithm, and then they change up the equation to improve the program. Okay. And what happened is that they were able to verify that it has improved tremendously. Okay. As you can see, the original, right? And then the performance too. So when you modify the equation or the algorithm on how you solve that problem, you would see that that's probably one of the best way that we can improve that program. Okay. So think about how you calculate. Something could be simple as in like finance software or, tax software, things like that have a lot of, algorithms, procedures that would be included. So we want to be able to think about how we would optimize those. All right. So for number 10, we can say that line profiler module. We use the line profiler module with the functions that would need optimization. We would use it to determine the costly statement, right? It would go through line by line. It would look at the costly statement, and we saw that the for loop require 10 to 20% of the cost. We can apply the decorator to the function that we intend to monitor. So you focus on the function that will be costly, and you would apply the decorator there if you're running the line profiler. And to produce the profiling output for our program, we just need to add the decorator to the evolve function. That would be the example. So you would put the decorator above the definition for that. Okay. So I think what will happen is that as you go through content of this class like this, every time that you achieve certain things like profiling and benchmarking, this is something that industry asks for. You should start putting stuff into your portfolio. If you're not using like Google, site or GitHub, things like that, you should start doing that. That way you can use that on your LinkedIn or your resume so people can see your work. Okay. And then if you're looking for the job that apply this type of skill sets, there are lots of jobs that require Python knowledge, and this is actually a higher level Python knowledge. So it's important that you maintain your information that you give out to employers for your career development. Okay, so once we get the benchmark and the profiling result, what can we do, right? How can you improve your code? Like I said, you would want to look at your algorithms and improve the algorithm. Or simple thing is to reduce the number of instructions in the code, right? Less tasks, less execution. So how can we streamline that? How can we reduce the instructions? You need to think about how you can simplify and reduce your instructions. Last one is going to be the DIS module. And DIS stands for disassemble. DIS module is used to inspect the bytecode instructions because ultimately all the statement that you have written, it needs to break it down to lower level and eventually, right? Instructions is going to be bytecode. So that way it can be executed. So the module that you can use to inspect the bytecode instructions is the DIS module. It would allow you to discover the statement that can be converted and served for Python bytecode representation. So to reduce the number of instructions in our program, we can evaluate, first we would need to evaluate our bytecode and see how we can reduce it down to less instructions and still be able to achieve the same thing. We don't want to reduce instruction and not be able to achieve our goal, right? We want to reduce it so that way it can be better performed. And you will find the DIS module information on the last part of your notes. Starting on page 14. Okay, it gives you various examples from the Taylor program. So when it gives you the output, it's going to look like this. And I didn't include another question for memory profiling, but memory profiling is important. So for Python program, you can use memory profiler. It works like line profiler. What it does is it evaluates memory allocation in your program. And you can put the decorator on the function that you would want to profile. Okay. So here's the example for that using IPython. Now, what it's going to do is going to give you the size, okay, of memory in megabytes, MIB. So you want to be able to compare the size of the memory. So the example that they use is, using slots, and then they improve it and then they rerun it. And so you can see that there are minute changes in the memory, but it is better. Okay, so how they rewrote that section of the code, it actually optimized the program by reducing the memory usage. Okay, so we have to be thoughtful about how we allocate RAM or memory for our application. Okay, so there you can see the comparison between the original, and then afterwards they had implemented, they improved this right here under class particle. So this basically, it reduced the storage of variables. And when you reduce the variables, because it's instantiated, you remove, right, unnecessary memory allocation.
Is that a built-in function because it has the double underscore?
Yes. So you use slots, and then what you do is you pass in the variables here, even though you initialize them down here, right? So what that does is instead of using it, instead of cutting multiple, it's going to reference how you initialize down here. So basically it uses what it says, instance of the internal dictionary. So the best way to really approach this is to really understand, right, the functionality of some of the built-in functions or the built-in components to Python and its capability. Okay, because you can write your program, it's still going to run, it's still going to have all of that. But if you want to shave off some memory allocation, then we would need to think about how we can, maximize that. Okay, we can maximize our memory usage by reusing some of the allocated area. So in development, right, analysis, you can get into testing applications and stuff like that, and this would be the area. And Python has abundant, tools and resources that you can refer to, which is great. Questions? So let me put back this. Yeah.
I mean, is that really a big thing? Because the variables, they disappear after the function is run anyway.
Right.
So
well, at the end, after your program is ran, right, it will give it back. Supposedly it's supposed to clean up the garbage and it gives it back to the system. But if you have a very extensive program, right, that's what they're talking about, like libraries and things like that, or graphic-based type of application, 3D animations, things like that, you should consider, right, thinking about design and how you would improve that design over time. Because in the smaller scale program, we don't worry about it too much, but in the very extensive program. So when you think about VR, stuff like that would be considerable, or, you know, or even AR, augmented. So, or image recognitions, things in nature that would utilize a lot of RAM.
Okay.
Number 6. Okay. Yep. Okay. So this question about number 6 real quick, but what would be the case pytest not work in the test 1? Coming back to 6. So make sure that you are in scripts. If you run it, so Alex, what part did it not work for you? Which steps? Number 1, earlier, if you issue this, right, basically Python path is not set up. So you just need to install, make sure you check setup system path. Make sure that your Python file is in your script. Make sure that you install pytest. Okay. I tested this 5 times, so okay. Okay, she said she can't find the files. Okay, so the files are located. Are you talking about the Python files? They are here. Once you download, you just copy it over to your scripts. So if you follow the test, right, you would have, I did it with the test 1, I'll show you. Okay, you would have a test env. You need to put those files in here. Okay. I have an en one. Yep. So you gotta put these files in there. The test simul and the simul needs to be in there. My alarm clock's 7 o'clock, so sorry. All right. I'll hang on for a few minutes. Let me stop share so I'll help you troubleshoot it. Okay. All right, everybody else, if you're finished, type in your name for attendance record. Have a wonderful evening. I'll stick around for a few minutes for questions. I do have a lab with 25 at 7:30. So I will post the video and then I can also address additional question later on Wednesday if you have questions. Okay, so Sonali, did you need some help? Let me stop recording real quick, okay?